Good day, guys. We are now looking at center of gravity on Math 96. So we'll go through this question as before. It says make the sketch of y equal to the square root of 9 minus x squared and show the strip that you will use to calculate the volume generated when the area bounded by the graph and the x-axis rotates about the y-axis. So after that, we'll calculate our volume, then we'll calculate the distance of center of gravity from the x-axis. So from reading my question, that's the information I've gathered. So we'll go to the A part. In the A part, I've got two main graphs. There is y equal to the square root of 9 minus x squared, and there is the x-axis. So the x-axis is the graph y equal to 0. So we're going to sketch that graph, and then we show the area bounded by that graph and the x-axis. So the area should be bounded by two graphs. Then whenever you read a problem of volume, since our target is to calculate the volume, it's very, very important to know your rotation. So we've got y-axis rotation, which tells me that if I start calculating volume, my formula must start with Vy. So let's go to the graph. So that graph up there, for those who are familiar with graphs, they will see that that is the graph of a semicircle, because it's like you got x squared plus y squared equal to 9, then the make x the subject, y the subject to get 9 minus x squared, and then take the square root to get half a circle. So you see that it's coming from a full circle, so that gives us half a circle. So when you make y the subject and it is positive, like you see in our problem, it's the upper half of the circle. So it's supposed to be like that. So if you look at it from that circle, you will see that your radius is supposed to be 3. So if we happen to make y the subject, and we have a positive sign here, because from taking the square root is supposed to be plus negative. If we use the positive, then we're dealing with the upper half of the circle. But if they had used a negative, it will be the lower half of the circle. If they make x the subject, we'll be dealing with the right half. Y the subject, x the subject with positive is the right half, negative is the left half. So those are the little techniques you need to know from sketching graphs. So that is our graph. So we have our 3 and our negative 3. So we are told to show the area bounded between the graph and the x-axis. So you can see that's your graph, that's your x-axis. So the area that is bounded between the graph and the x-axis is this one. There was no indication as to whether we are staying in the first quadrant or in the second quadrant. So you see, I'm showing everything, because the question says you should sketch the graph and show the strip that you will use to calculate the volume generated when the area bounded by the graph and the x-axis. That's the graph, that's the x-axis. So looking at that shaded portion, it's possible that we can put any strip there. It can be vertical, it can be horizontal. So I will start with the vertical one because it's a bit easier. With the horizontal one, there are some technicalities there. Since I've shaded all through and I put it here or there, it doesn't matter. So I'm putting my strip there. So that's my strip. So when I put a vertical strip, which tells me that the first graph passes above the strip, that's y1, which is square root of 9 minus x squared, and the second graph passes below the strip, that is y2, which is 0. And here I've forgotten that I have to put a 3. This is the origin. So I'm done with my graph. So it's now time to calculate the volume. So to calculate the volume, the formula, you must start by looking at your rotation. As indicated, my rotation shows that I start with Vy. So my formula starts with Vy. Then the way my formula ends, I look at my strip. If it touches the x-axis, my formula ends with dx. So that will be my formula. Then for an N6 student, you just go to page 5 of your formula sheet, you search for that formula. So if you're looking for that formula, you see that you have 2 pi, the integral from a to b of x, y, dx. So that is the way your formula is. But since on our graph we've got y1 and y2, you are free to also accommodate them, so that in the case where y2 is not 0, it will be taken care of. So if I want to accommodate that, I'll just capture my formula that way. But I'm not saying capture it that way is wrong. There is nothing wrong with that. So that's how our story looks like. So that's our formula, and this formula is called the shell method of calculating volume, because you can see that our axis of rotation is the y-axis. The strip is parallel to the y-axis. So that's how the shell method looks. Or once you see 2 pi, it's the shell method. So I can now start substituting. My limits are from -3 to +3, and we have x in bracket y1, it's the square root of 9 minus x squared, y2 is 0, so that is basically what we get. Then we can do our integration. So one thing we must pick here is that even though our limits are from -3 to +3, you realize that since rotation is about the y-axis, it means the other side is created from rotation. So you're supposed to concentrate your limit only in the portion where you've put your strip, which should just be from 0 to 3, because the other side is taken care of. If you have put your strip here, you will take it from -3 to 0. Since we put our strip here, it's from 0 to 3. When we do the rotation, the other side it's taken care of. So that's how it looks like. Then this is what I'm integrating. So if you check, this is a product. So once you're looking at the product, you'll see it's U substitution, because you can differentiate x squared to get 2x. But for N6 students who are familiar with the power rule, they will know that that is the fastest way of doing U substitution. So rather than going through that, I will capture my formula like this. If you want to say let u be 9 minus x squared, is fine, but it takes time. So this formula is on page 4 of the N6 formula sheet. So all I need to do is to arrange this portion to resemble the formula. So if I get back to my problem, my Vy is 2 pi, then the integral from 0 to 3, then the part that I'm supposed to call my u in my u substitution, I put it in the position of f. So certainly my u is 9 minus x squared, my power is a half since it's a square root. Then the formula says we must see the derivative of f next to it. So if I differentiate 9 minus x squared, it gives me minus 2x. So before I get out of the formula, I must confirm whether what I've written here is it still the same thing there. You see that there is a small difference of -2. So I need a number that can take care of the -2, which is -1/2 outside. So this, my u substitution is finished. So I'm left with -pi outside to write my answer, and then use the right side. The f that I put there must go there. So I will get 9 minus x squared to the power 3/2. You see the power is increasing by 1 divided by 2 from 0 to 3. So what I've done there is the same thing like somebody saying let u be equal to 9 minus x squared. You get your du dx, you make dx the subject, and so on, and you do your u substitution properly. So it's now time to substitute my limit. So if I'm substituting my limit, Vy, I start with the upper limit. You see I'll have to put 3 there. If I put 3 there, 3 squared is 9, 9 minus 9 is 0, so the upper limit is a 0. Sorry, before I go there, I have -pi out, then minus, I start the whole process again. I recopy everything with -pi, then I take my lower limit. My lower limit is a 0. If you put 0 there, you get 9 to the power 3/2 divided by 3/2. So those two can be positive. Then I can use my calculator to check what is 9 to the power 1/2 by 1,5. So that gives me 18 pi. So if I am fine, then my answer is 18 pi unit cube. If you want to check what is the meaning of 18 pi, it's also fine. You can still put your answer in decimals, which will be 56,549 unit cube. So you can either leave your answer of volume in terms of pi or in terms of decimals. So that's how we get our volume. Then we can now go to the last part, which says calculate the distance of the center of gravity from the x-axis. So the meaning of that, distance of center of gravity from x-axis, is simply the y-ordinate of the center of gravity, which on page 5 of our formula sheet is defined as volume moment about x over the volume. Now the volume is the 18 pi we've got. So what we need now is our volume moment about x. Our formula sheet, page 5 again says this is r dv. So to develop this formula, I start by copying my formula for the volume. You see the formula we use there, that is our shell method, which is 2 pi. So in the place of dv, I'm copying that formula for the volume. It's 2 pi, the integral from a to b. Leave space for r in there. If I prefer that one with x1 and x2, then I'll get x into y1 minus y2 dx. Then now I look for my r. So to get my r, the story of r does not change. The key player here is that axis. So to get r, I must go back to my graph. I start from the center of the strip and move to the x-axis. So if I get back to my graph, I start from the center of the strip and I move to the x-axis. You see, that will be my direction of movement. So my direction of movement is vertical. Normally, I should be saying my r is y, but whenever my strip is in the same direction as my definition of r, I take the average of the two graphs, where the mathematics behind this says your strip is like a thin line with y1 up, y2 down there, then your r, you are taking the distance from the center of the strip, so you see what you are looking for is actually the midpoint of that line. So that's where we get our r being y1 minus y1 plus y2 over 2. So with this 2 goes out to make 2 pi, so that I have pi, the integral from a to b, then I'm left with x in there. y1 plus y2 to y1 minus y2 is y1 squared minus y2 squared dx. Then I can start substituting my information as before. The integral from 0 to 3 of x into y1 squared. You still remember what was our y1? Is the square root of 9 minus x squared. So I'll get 9 minus x squared. Since we're squaring it, you take off the square root. Our y2 is 0. So that's what we get. Then if we continue here, our volume moment about x is pi outside, the integral from 0 to 3. If you open that bracket, you get 9x minus x cubed dx, which if you integrate, you will get 9x squared over 2 minus x to the power 4 from 0 to 3. Then you substitute your upper limit. If you put 3 there, 3 squared is 9, 9 times 9 is 81 over 2, 3 to the power 4 is another 81 over 4. Then your lower limit is a 0. Then that gives you 81 over 2 minus 81 over 4 times pi. Forget 81 on 2 minus 81 on 4. That gives me 81 over 4 pi. So again, 81 over 4 pi unit to the power 4. That's the unit of that, which can also be written in terms of decimals for those who prefer decimals. That will give us 63,617 unit to the power 4. So that's your volume moment, and therefore the y-ordinate of the center of gravity is simply the volume moment, which is 81 over 4 pi divided by the volume. If I'm looking at that formula, our volume, we were 18 pi. So if you do that division, we'll be getting divided by 18 pi. That gives us 9/8, which is the same thing as 1,125 units. So that is your y bar. For you to confirm that this is correct, you must go back to the graph and check whether the y ordinate of the center, does it lie within the shaded portion. So the shaded portion we are dealing with is this one. You see in your diagram, which lies between 0 to 3, and you can see that the center must be a number along the y-axis between 0 to 3 and closer to the base, because the diagram is bigger as you get to the base. So that's why we get 1,125. So guys, thank you. That's center left.